Hey everybody, Mrs. Bixler here, and I'm going to talk to you today about what is arguably one of the most important things that you learn in algebra, and that is factoring. So we've heard the word factor a lot, and this is something you heard even back in your elementary school days. We talked about factors, like if somebody asked you for the factors of 45, what they mean is what numbers do you multiply together to get you 45? So you would sort of go through like that rainbow or the factor tree, and we'd say, well, I know that 1 times 45 is 45. I know that 3 times 15 is 45. I know that 5 times 9 is 45. And those are all factors of 45. And what we've done here is we've said we're writing sort of 45 as a product. It's a product of two numbers. And what two numbers do I multiply together to get us 45? That's what factors are, and that's what factoring is. We also talk about common factors a lot. So here's a little example. I didn't feel really well after breakfast on Monday, Wednesday, and Friday. And so I decided to write down all the stuff that I ate for breakfast those days. So Monday I ate oats, banana, and walnuts. Wednesday I ate oats and walnuts, and Friday I had walnuts, banana, and an apple. And so, looking at these, can you find the common factor here? What on earth could be making me sick? So if you looked, you see, oh, wait a second. There are oats in the first one, oats in the second one. Shoot, no oats. Wait a second. There are walnuts on Monday, walnuts on Wednesday, and walnuts on Friday. So if I were to take out that common factor, maybe I wouldn't get a stomach ache on Monday, Wednesday, and Friday. So the common factor is something that is involved in each one of these days. And we can translate this into math. What if I gave you an expression like this? So again, 3 days, right? Like Monday, Wednesday, Friday. What's a common factor in each one of these? Well, look, each one has an X. Amazing. But also look at the numbers. Do you see how each one has a 2 in it as well? So I could take out those common factors, and bear with me here. If I take out a 2 and an X out of each one of these terms, what would be left? So 2x, and I need to get a 2x squared y. Well, what's left is an x and a y. Because if I distribute this 2x to the x and y, do you see how you wind up getting 2x squared y? So you're going to do the exact same thing for the next one. Well, what would I have to multiply 2x by in order to get 4x? Well, a 2. And then last one, this would have to be a 5y. So what we've just done here is we have factored out, this is a common factor, and we've factored out this 2x. And then look what we've done. We now have 2x times this xy plus 2 plus 5. We've now just factored this into this. We have written that first top thing as a product. That's what factoring is. And guess what? You have already done this year. Remember when we saw problems like this and we said, oh my God, we've got an x squared term, an x term, and nothing else? I know that this is ZPP. This is great review. It is the zero product property. Look, we've got a zero here, but we don't have a product. So what did we do? We factored out, we didn't call it factoring, but we factored out the common term out of each one. So look, I had take out an x and I'm left with an x plus 5, and then we could solve. And remember how we talked about the way we could sort of check on the left-hand side to make sure that we hadn't made a mistake is we could redistribute this x to everything on the inside and make sure that we got what was written in red. So this is something that you did in the fall. You factored out an x. That is something that you've already done. So if you have an x squared term, an x term, and nothing else, you know that you can factor here. But what if I gave you a trinomial? And this is tricky. So if I give you a trinomial and I asked you to factor this, you want to write this as a product. And that's what we're going to talk about today. So we want to write this trinomial as a product. So let's go ahead. I want you to pause the video right now, and I want you to FOIL this guy and tell me what trinomial you get. All right, so hopefully after you FOILed this out, you got x squared plus 9x plus 14. If you didn't, go back to the FOILing video, watch it again, make sure you feel good. So that's FOILing, right? So we start with a binomial, we FOIL, and we get a trinomial. Factoring, we start with the trinomial and we go back to the binomial. So if I am factoring, I'm going the opposite direction. Start with a trinomial, go to a binomial. Cool? This is sort of the general process here. All right. Because I'm the greatest teacher ever, I have just FOILed out these 3 pairs of binomials, and I've given us trinomials. So I want you to look at these guys. Pause the video for a second, and I want you to see if there's any relationship between the numbers here. All right, so if you look, looky-loo, this 14 comes from adding 4 and 10. And this 40 comes from multiplying 4 and 10. So, that's interesting. Let's see if that happens down here. So my 7 comes from 2 plus 5. And oh my gosh, 2 times 5 is 10. Let's see if this happens down here. So -2 plus 5, -2 plus 5, look, is a positive 3. But -2 times 5, -2 times 5 is a -10. Huh. So that's kind of cool that they've got that relationship. So I wonder what would happen if I gave you this first. So I'm going to start with the trinomial and I'm going to try and go backwards. So again, I'm going to go back to this guy. So look, if I start with this top one and I said, all right, I'm going to do x squared plus 14x plus 40, and I want to write that as a product. So I would now want to write it as that binomial. Well, I can think of factors of 40, 4 and 10 that combine in some way to give me that 14x. So let's try it here. So let's think about factors of 16 that combine in some way to get me a 10. So my factors of 16, I have 1 and 16. I have 2 and 8. Ooh, that's nice. 2 and 8. When I add 2 and 8 together, I get a 10. Look what I do. I make my little binomials. I like to draw them both first. I've got my x's in here. And then I know that whatever is left in here, the 2 numbers that go in these slots, when I add them together, they get me 10x. And when I multiply them together, they get me 16. So if I put in a 2 and an 8 here, we can say that this is now the factored form of that trinomial. And the way that you check is just the way we did with ZPP. Go ahead and do a quick little FOIL out. So if I FOIL this guy out, I get x squared plus 8x plus 2x plus 16. If I combine my like terms, look, do I get that original problem? I do. So I'm good. All right, let's try the next one. All right, this one's a little tricky because we've got negatives involved. So again, let's look at this. And I just want to look at 15. Don't worry about -15. So I want to find factors of 15 that combine in some way to get me a -2. So factors of 15. All right, so 1 and 15, 3 and 5. All right, good. So I know 3 and 5. All right, so how can I combine 3 and 5 to get -2? So, all right, let me just make my kind of outline first and think about what goes in these 2 slots. So I know I need a -2 with 3 and 5. Oh, I know. I can do a -5 and a +3. And if you did it in another order, if you did it this way and you said x plus 3 and x minus 5, it don't matter. That is the exact same thing. If I FOIL these guys out to double check, let's see what I get. X squared minus 5x plus 3x minus 15. Combining like terms here, I get x squared minus 2x, nice, minus 15. So I get my original problem. But please note that if you instead did x plus 5 and x minus 3, let's see what we'd get. So x plus 5 and x minus 3, Now let's FOIL this out. So x squared minus 3x plus 5x minus 15. Wind up getting x squared plus 2x minus 15. And that's a different trinomial than the one we were trying to get before. We were trying to get a negative 2x in the middle. So where you put the negative matters, but if you swap the what's in the parentheses, that's okay. All right, let's try the next one. I want you to pause the video and try it on your own. All right, we are back. So you should have asked yourselves, what are factors of 9 that combine in some way to get me a positive 6? Well, 1 and 9, no way I can get 6. 3 and 3, amazing. All right, let's draw our little parenth, x, x, and I can do a 3 and a 3. Well, wait a second. These look exactly alike. You know what's cool about this? You can squash these suckers together and write them like that. Whoops, didn't mean to cross that out. So you can squash these two together and write it just like that, which is kind of cool. All right, let's try another one. So now I want you to try this one. So factors of 1 that combine in some way to get you a 3. Pause the video and try it. All right, we are back. So factors of 1. All right, so 1 times 1, and that's it. So shoot, there's no way that I can combine 1 and 1 and get a positive 3. There's no way. So here's what we would write here. We would write CBF, or cannot be factored, because this is something that can't be factored, and we'll learn how to deal with those later. All right. So here are the questions you want to ask yourself when you're factoring. And you'll see that these questions are numbered 1 and 3. That's because the thought process is missing step 2, and we'll get there. So the first thing you want to ask yourself always is there anything I can take out of each term? So here's a trinomial. And let's look, is there anything I can take out of each term first? Well, yeah, actually, there's a 2 in each one of these terms. So I want to get rid of that 2. So what's left on the inside? X squared plus 6x plus 9. Now that I've taken that 2 out, now I can do that plain old factoring right here, where we say, what are factors of 9 that combine in some way to get me a 6? So, we just did this one, right? So we did x plus 3 times x plus 3, right? And we like sort of squashed it together. So it looked like this. But then don't forget that 2 down in front. This would be your final fully factored answer. All right, here's another one. So I want you to take everything out of the first term, or everything out of each term that you can. A good rule of thumb is we don't want a negative leading coefficient. So let's take a -1 out of each term. So what's left on the inside? X squared minus 3x plus 2. The way to ensure that you've done this correctly, remember, is you can go through and redistribute. So now, all right, let's do plain old factoring. Are there factors of 2 that combine in some way to get me a -3? Well, 1 and 2. How can I get those to get a -3? Oh, I know. X minus 1 times x minus 2. And let's just double check with our foiling. I get x squared minus 2x. Oh, minus another x, and then plus 2. X squared minus 3x plus 2. Amazing! But don't forget that -1. It's got to go in front. And then this would be your final, answer. All right. So the big thing here that we have learned is that when we are trying to factor, we are going to write it as a product. And you always want to ask yourself, is there something I can take out of each term first? And so that's like when we're looking for 2's or things that make things a little bit messy. And then you're going to go into plain old factoring. So go ahead, try the worksheet. You're going to crush it. And I'll see you guys soon. Thanks.